All right, so have you ever really stopped to think about what happens the second you swallow a pill? I mean, it seems like magic, right? But it's not. It's actually this incredible two-part story unfolding inside your body. So let's dive right in and unpack that.
Yeah, the moment that pill goes down, you're basically the director of this complex two-act play happening inside you. It's this amazing story of a journey and a mission, a real delicate dance between your body and that medicine.
No, seriously, think about it for a sec. How in the world does that tiny painkiller know exactly where to go? How does it navigate the, absolute maze of your body to find and shut down your headache? Well, like I said, it's not magic, it's science, and it has two very distinct but totally connected sites. And here they are, the two big players, pharmacokinetics and pharmacodynamics. Okay, I know, those are some hefty words, but here's the easiest way to break it down. Pharmacokinetics, let's just call it PK, that's all about the drug's journey. It's what your body does to the drug. Then you've got pharmacodynamics, we'll call it PD, and that's the drug's mission. It's what the drug does to your body. See? Journey and mission, they're two sides of the exact same coin, and you absolutely need both for anything to work.
Okay, so let's jump into Act 1, pharmacokinetics, the journey. The second a drug enters your system, your body just springs into action. It's like, whoa, what is this new thing? And it starts to process this foreign substance. This is the drug's truly epic journey.
So a really simple way to picture pharmacokinetics is to think of it like the drug's personal GPS or its delivery route. It literally maps out the entire trip the medicine takes, from the second it gets in to the very moment it leaves your body. In this journey, it's got four main stages. And scientists came up with this really handy acronym for it, ADME. That stands for absorption, distribution, metabolism, and excretion. So let's walk through each one because this is where things start to get super interesting and really personal. First up is A for absorption. This is where the journey really begins. It's the drug getting onto the on-ramp of your biological highway, your bloodstream. And hey, this one step, this is exactly why some pills say take with food and others say take on an empty stomach. It's all about controlling how fast that drug gets absorbed and hits the road. All right, once it's in the bloodstream, we hit D for distribution. Now, your circulatory system takes over. Think of it like a massive Amazon delivery network, carrying the drug molecules all over your body. And what's wild is that some drugs are designed to just hang out in the blood, while others are expert travelers, great at getting into really specific tissues, like your brain. It's all about getting that package to the right address, right?
Next up, M for metabolism. Now, the drug arrives at this super sophisticated processing plant, which is mostly your liver, and this is where it gets incredibly personal. Your unique genetics, your age, even something as random as grapefruit juice, seriously, can speed up or slow down this process. And that is a huge, huge reason why the exact same dose of a drug can affect you and me completely differently.
And finally, we have E for excretion. The journey's almost over. The cleanup crew, led by your kidneys, gets to work, filtering the drug and all its byproducts out of your system. And this makes so much sense, right? It's why a doctor will tweak a drug dose if someone's kidneys aren't working at full capacity. They're trying to prevent a dangerous buildup. And with that, the journey is complete.
Okay, so the drug has survived its journey through the body. Now, it's time for Act 2, pharmacodynamics. This is the mission. This is the really cool part, where the drug finally gets to do what it was designed to do and make a real impact. So to understand this mission, we've got to talk about something called receptors. Just picture this. All the cells in your body are covered in millions of tiny specific locks. And a drug molecule, well, it's basically a key, precision engineered to fit into one of those specific locks, the receptor, to make something happen. But here's the thing. Not all keys work the same way. First, you have an agonist. This is like the perfect key. It slides into the lock, turns it, and boom, it sends a go signal, activating a response. Think about how caffeine wakes you up. That's an agonist at work. But then you have an antagonist. This one's more like the wrong key that gets stuck in the lock. It fits, so it blocks other keys from getting in, but it doesn't turn. It sends a stop signal. This is exactly how a lot of allergy meds work. They just block the histamine from getting to its receptor.
So here's where it all comes together. The really crucial point is that for a medicine to actually do its job, the journey has to perfectly set up the mission. The pharmacokinetics, that whole ADME process, has to deliver just the right amount of the drug to just the right place for just the right amount of time so that the pharmacodynamics can kick in and work its magic. And this is the perfect way to visualize that balancing act. What you're looking at here is something called the therapeutic window. It's pretty straightforward, really. If the drug concentration in your body is too low, well, nothing's going to happen. But if it gets too high, it can actually become toxic. So the whole goal is to stay right in that middle ground, that therapeutic sweet spot.
And honestly, that is the entire game in pharmacology. It's all about managing the drug's journey. That whole PK profile, to make sure the concentration lands smack dab in the middle of that sweet spot. That's where it can pull off its mission effectively without causing any harm.
Okay, so we've gone through a lot of science, but why does any of this actually matter to you? Well, it has huge implications for your health and for every single medicine you might take.
Well, understanding a drug's PK and PD profile is literally how your doctor decides, well, everything. It's how they figure out the exact right dose for you, how often you need to take it, what side effects you should watch out for. It's the absolute foundation of safe and effective medicine. And beyond that, it's what's paving the way for the future, truly personalized medicine. So, the next time you take a pill, maybe you'll think about it a little differently. Remember that incredible two-act play that's unfolding inside you, the journey and the mission. And it really leaves us with a fascinating question, doesn't it? As we get better and better at mapping out each person's unique journey and mission profile, are we heading towards a future where drugs aren't just tailored to a disease, but to your body's very own personal story?